Hello everyone, today we will be starting M2 Mechanics 2 of IEL Mathematics. First of all, we'll be learning chapter number 1, which deals with projectile motion. For projectile motion, the prerequisite that we need to learn is the SUVT formulae. I hope that we all know the SUVT formulae. The SUVT formulae go as follows: V equals U plus AT, S equals UT plus half AT square, S equals Vt minus half AT square, S equals U plus V by 2 times T, and V square equals U square plus 2AS. Now, in order to understand the formula fully, we need to understand what each of these parameters mean. T is the only parameter that is a scalar quantity here. All the other quantities are vectors. A stands for acceleration, V for final velocity, U for initial velocity, and S for displacement. Now we must recall that displacement and distance have a difference. For instance, if a particle goes from point A to point B, and the total distance and the total length of this path is 10 meters, then the displacement of the particle will be somewhat less than 10 meters. It could be somewhere around 7 meters. So the displacement is basically the straight line distance between 2 points in a particular direction, and the distance is the actual length of the path taken. For testing our concept, we will be learning some examples. For now, I am going to be looking at example number 3 of the book. A particle is projected horizontally with a speed of u meter per second from a point to 122.5 meters above a horizontal plane. The particle hits the plane at a point which is at a horizontal distance of 90 meters from the starting point. Find the initial speed of the particle. So, for this problem, we will first construct the diagram. The diagram is already constructed in the example, but I am going to show you how you can construct the diagram on your own. So basically they have said a particle is projected horizontally. So we have a particle that has been projected horizontally. So projection means throwing something. Projection means throwing something with an initial velocity. Horizontally means there is no vertical component of the velocity. The particle has been thrown just horizontally in a straight horizontal line. So we have an initial velocity of u meter per second from a point 122.5 meters above a horizontal plane. So we also have a horizontal plane right here, and the particle was thrown at some point that is 122.5 meters above this horizontal plane. Right. And it lands at a distance of 90 meters from the starting point. So this particle hits the ground at a distance of 90 meters. So here there is a confusion whether the distance of 90 meters is this distance or the horizontal distance. They have specified in the question that the distance is a horizontal distance, so this distance is 90 meters. The distance from here to here, 90 meters, not this distance. So the particle trajectory goes somewhat like this. This is the particle trajectory. And we need to find the initial speed of the particle. For that, we will once work with the horizontal component of motion and then the vertical component of motion. One thing to note is that when we work with the horizontal component of motion, we totally ignore the vertical components, and when we work with the vertical components, we ignore the horizontal, like so. First of all, we will be working with the horizontal components. So, working with the horizontal components, we know there is only one formula for the horizontal component. The formula is S equals Vt, right? So we know that the horizontal distance traveled by the particle is 90. We know that the horizontal velocity was u. How do we know that the horizontal velocity is u? That is because u was a purely horizontal velocity. If u was something like this, then we would have needed to find the horizontal component and the vertical component. But since u was purely horizontal, so the entirety of u was the entire horizontal component, like this, 90 is equal to ut. And now from here, t is also unknown, so we cannot find the value of u yet. So we move on to the vertical component of motion. As for the vertical component of motion, there is acceleration. So the formula that we have to use for the vertical motion is the SUVT formula, the set of the SUVT formula. Now in order to understand which formula from the 5 formulae to use, we need to identify what we need to find out and what are the things that we already know. So do we know displacement? Yes, we know displacement. The displacement is actually 122.5 meters. So the displacement is 122.5, and for this question, this particular question, we are taking the downward direction as positive. So this is up to you whether you take the downward as positive or the upward as positive, but whatever you do, you need to maintain consistency throughout the entire math. Now, as for the initial vertical velocity, the velocity that our particle had was a purely horizontal velocity. So there was no vertical component of the velocity. So initial vertical component of velocity was 0. Now, do you know the final component of the vertical velocity? No. Do we need to find it? No. So we totally ignore the final component of the vertical velocity. We know that the acceleration downwards is 9.8 meter per second square. And since it acts downwards and we have taken the downward direction as positive, so this is a positive value. Now time, we don't know the time also, so the time also remains unknown. So from this setup, we can see that we know S, we know U, we know A, and T is something that we need to find out. Now why do we need to find out T? We need to find out T because T is unknown here. If we plug in T, then we can find out the value of U. Now we can see that we have to use a formula which contains S, U, A and T, and that formula is nothing but S equals UT plus half AT square plus half AET square. This is the formula. So S is 122.5, U is 0, A is 9.8 and T is unknown. That gives us the value of T to be 5 seconds. When we input this value of 5 seconds in the previous equation, we get the value of U to be 18 meter per second. So that is the velocity with which the particle had been projected. Moving on to the next section of this chapter, we'll be learning how to find the components of a particular velocity. The math that we did previously had its velocity purely horizontal, so we did not have to find any component of the velocity. As for velocity or any other vector, the formula or the method of finding the components are as follows. So if there is an angle of theta and we want to find the component in this direction, the direction which is along the angle is the cos component and the other is the sine component. Let me repeat this process. Now I need to find the component of my velocity in this direction and this direction, but my angle is taken along with this direction, so this is the cos component, V cos theta, and this component automatically becomes V sine theta. This is the method of finding the components. Another thing that we need to revise at this point is the concept of vectors. We know that the horizontal rightward vector is denoted as the I vector and the vertical upward vector is denoted as the J vector. So if we have a vector that goes like this, minus 3i plus 5j, it is nothing but minus 3, 5 in column vector form, and it is just like a coordinate. It is just like a coordinate, minus 3, this is the I component, and 5, that is the J component. So our point is somewhere around here. But the difference with coordinate geometry is that we draw a particular line to show the direction of this vector, like this. This line we don't have in the coordinate geometry, but we have it in vector. So using these two concepts, we will be trying example number 4, where a particle is projected from a point on a horizontal plane with an initial velocity of 40. So we have an initial velocity of 40, and we don't know at what angle it has been projected. So we don't know whether the velocity is purely horizontal. So let us not draw the velocity yet. We know that we have a particle. It is projected from a point on a horizontal plane. So the particle was initially on a horizontal plane and it has been projected with an initial velocity of 40 at an angle of alpha above the horizontal. So we have an angle of alpha. We can draw this angle of alpha above the horizontal or below, but the question has specified that it is above the horizontal, so we draw above the horizontal. We cannot assume that the velocity is above the horizontal. We need to see it from the question. This angle, as the question tells, is alpha, and the initial and the velocity is something that we need to find out. The velocity is actually 40. We need to find out the horizontal and vertical components of this velocity. As for this alpha, they have told us that tan alpha equal to 3 by 4. Now from there we can find the value of alpha, and we can easily find the value of sine alpha and cos alpha. However, there is a more direct method of finding the sine alpha cos alpha without finding the value of alpha itself. That is a Pythagorean triangle. The question tells us that the value of alpha is such that tan alpha equals 3 by 5. This is what it said in the question, 3 by 5. So 3 by 4 actually, not 3 by 5, this is 3 by 4. So if you find the value of the hypotenuse from this Pythagorean triangle, we can see that the value is 5. Now we can use the same triangle to see that the value of sin theta is, sin alpha is 3 by 5 and cos alpha is 4 by 5. This is 4. The first requirement is finding the horizontal and vertical components of the initial velocity. So we have the initial velocity here 40. We know that the horizontal component will go somewhere around here and the vertical component will go here. The horizontal component contains the angle, so this is a cos component, that is 40 cos alpha, and the vertical component automatically becomes 40 sin alpha. We know that the value of sin alpha is 3 by 5, the value of cos alpha is 4 by 5. From there we can find out the value of the vertical component to be 24 and the horizontal component to be 32. This is actually done in the example. I'm just showing you how the example has been carried out. As for the part B, we just need to express this velocity in terms of our column vector. So in column vector form or just in vector form, we know that the I component resembles the horizontal component, the j component resembles the vertical component. Now, usually we take the upward direction as positive. So we will take the upward direction as positive in this particular math and the rightward direction as positive. So our horizontal component of the velocity from this diagram is positive 32 and the vertical component is positive 24. Why positive? Because this is rightward. Why this is positive? Because this is upward and we have taken these directions as positive. Now incorporating these horizontal and vertical components in our vector, we see that our velocity vector is nothing but 32y plus 24j. Moving on to a bit more difficult concept of this chapter, we will now be working with the greatest height and the range and the time of flight of a particular projectile. So as you can see from the diagram in section 1.3, a projectile motion actually follows a parabolic shape, and this point is the point of the greatest height, and the total time taken from here to here is the time of flight, and the horizontal distance that a particle travels from its starting to the final point is called the range. So the maximum height and the time of flight, these are all self-explanatory, but if the question tells you to find the value of range, you should know that the range is nothing but the total horizontal distance covered by the particle. So the range always doesn't have to be from ground to ground. If a particle, it starts from the ground and ends up somewhere on a higher level like this, the range is nothing but the distance from here to here. This is the range. This is the value of the range. Moving on to the example number 6. A particle P projected from a point O on a horizontal plane with a speed of 28 at an angle of elevation of 30. Here we have another concept that we need to discuss, angle of elevation and depression. So one way that the question can tell us at what direction the particle has been thrown is above the ground or below the ground. But if a particle has been projected from such a point that is like a tower and it does not tell us whether it has been projected above or below, the question might tell us the angle of elevation or depression. So angle of elevation means the angle from the horizontal in an upward direction. Upward means like this, from the horizontal plane in an upward direction. Angle of depression means from the horizontal plane on a downward direction. This is the angle of depression. So this that you see is the angle of elevation, and this right here is the angle of depression. The question tells us that our particle has an angle of elevation of 30. So the particle has been thrown such that it looks like this. The particle has been thrown from a horizontal plane projected on a point O. The point O is on a horizontal plane. Particle has been thrown like this at an angle of elevation of 30. So the angle is actually above the plane, and this angle is 30, and moves freely under gravity until it strikes the plane back at A. So the projectile of the particle looks something like this. It starts from this point, travels all the way, and lands over here at point number A. So this is the final point of the particle, and we need to find the greatest height above the plane reached by P. P is our particle, so we need to find the greatest height. We can easily understand that we need to work with the vertical component of motion. Starting with the vertical component, we should recall that we have acceleration in the vertical component, the acceleration due to gravity, so we need to work with the SUVAT formula. Displacement we need to find out because we are working with the maximum height which goes under displacement, so displacement is unknown. Now for the initial vertical component of velocity, we know that our initial velocity is 28 meter per second from the question. From there we can easily find out that our initial vertical component is nothing but 28 sine 30, that is actually 14, and the horizontal component is 28 cos 30. Right, so our initial vertical component, see we're working with the vertical component of motion, so we will only take the initial vertical velocity, which is 14. When a particle reaches the maximum height, what is the velocity, the vertical component of the velocity? The vertical component of the velocity at maximum height is always 0, and the acceleration is negative 9.8. Now how do we come to this conclusion? It is negative 9.8. I have missed one step here. The step goes something like this. First of all, marking out which directions are positive for you. Now for this question, we'll be taking the upward direction as positive and the rightward direction as positive. So our upward direction, as we see here, it is a positive 14, the upward initial velocity. Since acceleration due to gravity acts downwards, so we have assigned a sign of negative to the acceleration. Time we don't need to find out, so we ignore time. We have to find a formula that uses S, U, V and A. From our list, we will see that the formula is actually V square equals U square plus 2AS. From there, we can find the value of S to be 10. So the maximum value of the height, the maximum displacement is 10 meters. The second part of the question tells us to find the time of flight of P. The time of flight of P. For that, what we can easily do is that we can use the V equals U plus CT formula. The V equals U plus CT formula. Once again, for the vertical component of motion, V equals U plus AT. We know that at the maximum point, the value of the velocity, vertical velocity is 0. The initial component of the velocity, vertical velocity, is 14. Our acceleration is minus 9.8, and T is something that we need to find out. Our value of T will be something like 1.45. So this is not actually the answer for the total time. The time that we have found out is the time taken for the particle to reach the maximum height. So actually the total time of flight is this time multiplied by 2, which gives us 2.9 seconds. As for the final component of our question, we need to find the range. The range is actually nothing but the distance that is traveled at a particular direction in the horizontal direction at the horizontal velocity. We know that range is only the horizontal component of the displacement. So actually this distance, the distance from O to A. We know that the horizontal component of motion is 28 cos 30. So the velocity we know. We know that the total time of flight from here to here is 2.9 seconds. So T we know. From there we can easily find the value of the displacement to be 69.3 meters as matched by the question, as matched by the example. To make things a bit more challenging, we will now be working with a projectile that goes a certain height, stays above that height and then comes back, and we need to find out for how long the particle stays there. So for solving this math, we need to be working with the conceptual understanding of the value of T from the SUVAT. The T here is actually the time taken for the particle to reach a particular displacement. Let me show you what that means. For example, a particle travels from here to here like this, and the S is actually the displacement from the ground, somewhere around here. So if we substitute a value of S in our equation and we get some value of T, that will give us the values of the time, for example 2, for example here 10, the values of the time at which the particle was at that displacement. So if we substitute a value, for example this displacement here is equal to 5 meters, if we substitute a value of 5 in our displacement and we get a value of 2 and 10, this means that our particle was at a displacement of 5 at 2 instances, at 2 second time and 10 second time. So for how long was the particle above the 5 meters? That is from 2 seconds to the 10 seconds mark, and this duration of time is 8 seconds. This concept is something that we need to work with in our example number 8. A particle is projected from a point O with a speed of 35 at an angle of elevation of 30. So once again we have a particle that has been projected with an angle of elevation. So we have a particle here, we have a plane, and we have an angle of elevation of 30, and the velocity is 35. Angle of elevation is 30. Find the length of time for which the particle is 15 meters or more above O. Right. So the particle goes something like this. It goes like this from here to here. 15 meter can be somewhere around here. 15 meters. So first of all, what we need to do is we need to find the times at which the particle is at 15 meters. And then we will subtract the two times to find the total length of time for which the particle was above 15 meters, as we have explained in the previous part, just the part before this question. So since it fully deals with the vertical motion, we'll be working with the vertical component of motion only and work with SUVAT. It is a good practice to write down the SUVAT because in more difficult situations it will allow us to correctly identify which formula to use. Now we know that our value of displacement will be 15. Our initial component of velocity will be 35 sine 30, that is 17.5, and we don't know our value of velocity or final velocity at 15 meters. So we don't know that. We don't need to find that out. So that is completely cancelled from our calculations. Now as we have taken the upward direction as positive, we have taken the upward velocity as positive. So the value of acceleration will be negative 9.8. And time is something that we need to find out. So now we will use a formula which uses S, U, A and T. The formula that clicks up is S equals UT plus half AT square. So all the things are unknown, all the things are known other than T, and by substituting all the values we get a quadratic equation which looks something like this: 4.9 T square minus 17.5 T plus 15 equals 0. From here we can see that we will get two values of T. The values of T turn out to be 10 by 7 and 5 by 7. 15 by 7 and 10 by 7. So these are the two times when the particle is at 15 meters above the ground. So this value is 10 by 7 and this value is 15 by 7. Now at what time what the particle was at 15 meters, 10 by 7 and 15 by 7. So for how long was the particle above 15 meters? Simply subtract the two values, and that is how we get the value of time for which the particle was above 15 meters, which is 0.71 seconds. So these examples should allow you to solve all the way from exercise number 1A to 1C. A second part of this chapter will be covered in the second part of this video, but do let me know in the comments if you want me to solve any particular other examples or any particular math from exercise number 1A, 1B and 1C. It is not possible to solve all the math, so after taking input from you, I'll be solving the math that you want me to solve. Thank you very much for watching this video.